I like to build Legos, and I like Star Wars. I like karate.
I like to cook. I like to read a lot.
I have a disease called muscular dystrophy, and it impacts my running, and it impacts my ability to do certain things like the monkey bars and stuff like that.
I have to go to lots of doctor's appointments.
I can walk, talk, and do all that.
I live life like just a normal person.
The downsides are is I can't do as many things as the other kids.
I'm pretty fortunate that I have a milder version of LGMD2C.
I think Peter and Kurt are an inspiration for kids with anything. The way that they can stand up for themselves and talk about their disease, realize their limitations, admit that it sucks, but still do all the work to, do their stretches, wear their braces, etc. I think can be an inspiration to all. It is not fair, but you also can embrace it and teach people about it and make a better outcome for you and others with this. And so I think Peter and Kurt really are great examples of that.
When Kurt was 3 years old, we knew that he was delayed in his motor skills. So we started the process of getting him checked out. After a period of 6 months or so, we came to the conclusion that he had limb-girdle muscular dystrophy type 2C.
LGMD means limb-girdle muscular dystrophy, and type 2C means it's a recessive disorder and it indicates the gene that's responsible. There are a lot of different forms of muscular dystrophy because there's a lot of genes that can have mutations that can cause this disease.
All of the muscular dystrophies are rare disorders. The group of muscular dystrophies, we're at about 1 in 5,000 individuals that are affected with the disease. When we go down to the level of LGMD2C, limb-girdle muscular dystrophy type 2C, it's much more rare. It's about 1 in 200,000, which equals about 1,000 patients in the United States.
We were really told that what we were looking at is there was no treatment, there was no cure, that we didn't know how severe the disease could be. It could be as severe as Kurt not walking into his early teens and not living past his 20s.
The way that I sort of dealt with grief was in part to go dig into the disease and try to understand whether there was some avenue for hope.
And we decided to form the Kurt Fund, which after Peter got diagnosed became the Kurt and Peter Foundation, and see if we could raise money, find someone who could pursue this research and work towards an eventual treatment and possible cure for limb-girdle muscular dystrophy type 2C, and that this could potentially help our boys, but even more broadly as we learned that the disease affects more people in Tunisia and Romania and Europe than it does even here in the United States.
So in Tunisia, limb-girdle muscular dystrophy type 2C may be as prevalent as Duchenne muscular dystrophy is here in the US. This disease is not only prevalent in Tunisia, it's also prevalent in Algeria, Morocco, Libya, North Africa in general, and also in the Middle East.
I spent my time reading up on for other forms of muscular dystrophy, and in particular became focused on exon skipping.
They just had never been thought to be tried yet in our type of the disease. I was able to connect with Elizabeth McNally at that time at the University of Chicago, and when she heard the idea, she thought we were crazy.
And that's what most people told us. Most people had told us, well-regarded researchers told us, don't bother, not worth it. But Beth's reaction was quite different. Dr. Beth McNally said, hey, wait, I agree, probably not gonna work, but for a very modest amount of money, we can test that hypothesis, and rather than guess, why don't we try it?
The Kurt and Peter Foundation has been a driving force in really trying this idea of exon skipping. When I first met Scott Frewing a number of years ago, Scott pushed me pretty hard to say, well, why can't exon skipping work for my sons? And in fact, I was quite certain at the time it probably wouldn't work, and luckily through his persistence, we actually tried it and we found out it does work. Limb-girdle muscular dystrophy type 2C is caused by mutations in the gene called gamma-sarcoglycan. Genes are made up of exons. Exons come together to make what we call messenger RNA that can then make the protein. Those exons are multiple little pieces that have to come together. In the case of limb-girdle muscular dystrophy type 2C, the gene gamma-sarcoglycan is made up of 8 exons. The most common mutation actually occurs in exon 6. And so if we want to make a mini protein that is functional through exon skipping, we actually have to skip exons 4, exon 5, exon 6, and exon 7. That leaves exons 2, 3, and 8 coming together to make the mini protein. So remarkably, it seems like you don't need the middle parts of the protein very much, and you can get by with about half of the size of the protein.
Gene therapy is using a virus. We use a virus called adeno-associated virus. It's a virus that doesn't cause any known human diseases. And so some very smart people decades ago discovered that you could take out the genes from the virus, the viral genes, and replace those with any gene that you want. So we put that into the virus, deliver through the bloodstream in this case, and through a vein, goes to the whole body. And then once it gets to the target, like your muscles, it delivers the gene that you want, and then it will express the protein that you want. The valuable part about gene therapy is that it's a one-dose treatment. So a single dose can last a lifetime, and we know from other diseases that it's been shown to last for several decades. That's as long as patients have been treated for. So the hope is that it will last for a lifetime.
We hope that by the summer of 2019 or maybe early 2020, that the gene therapy program that we're pursuing will be in the clinic with patients actually being infused with a healthy LGMD2C or a gamma-sarcoglycan gene.
Gene therapy and exon skipping could be used in combination. You could receive gene therapy very early on in life, and if you potentially needed a booster, so to speak, you could receive exon skipping later on to allow more generation of the protein. Conversely, you could start with exon skipping and then get gene therapy later on. So the nice thing about these two possibilities is that they could be used in combination and they would not affect each other negatively in any way.
That's our goal, is to have 2 programs in the clinic in the next 2 to 3 years.
To date, the skipping looks actually really promising in the cells. We can find some people skip a little bit better than others, and that's true for Duchenne muscular dystrophy as well. But by and large, we've been really surprised how well it works.
Skipping these genes can open the door to treatment of many other genetic diseases that are similar.
Once we show in even one of these subtypes that we can be effective, we can very rapidly apply it to the other subtypes and show efficiency, and I think that we can really make a difference because every day counts for these patients. So every day that we're not finding that treatment is important.
If we can get the drug produced in enough quantity to put into a clinical trial, that we'll be able to clinical trial in the relatively near future, which is really exciting.
The funding that we've received from the Kurt and Peter Foundation to us at Nationwide Children's has really enabled us to develop a gene therapy treatment, show that it's safe and effective in the lab, and that's really going to allow us to get to a clinical trial. So it's really been effective in helping us to get to that next level.
As we move down this journey, and we're now 7 years into this process, we have been able to see our kids grow, and we've been so grateful that they have done better than originally predicted, but we know that there's kids with their same disease who have not been as fortunate, and we now really feel like we're on the cusp of the next phase.
I would be really kind of sad and sort of, I think, depressed if we didn't have the foundation, because it gives a new possibility of cures or treatments for muscular dystrophy.
I think it's actually really good because it will actually benefit more kids than just my brother and me.
For me, the foundation is still our family being all in.